Jai Hind. Hello cadets. Now in the video titled Field of View, we have seen some uses of plane mirror as well as convex mirror. So we usually observe these kind of mirrors around us in our day-to-day life. Concave mirrors also are used in some of the applications. So in this video we are going to discuss those applications where a concave mirror is used, mainly because a certain type of reflection that it is capable of producing. Okay, the very first application is based on the simple image formation that we have seen in the beginning. When parallel rays, that is the rays of light parallel to the principal axis, are incident on a concave mirror, then after reflection they all converge at the focus or at the principal focus. Now imagine that the incident rays are coming directly from the sun. That is, all these incident rays, they are nothing but rays of sunlight. So after reflection, they will converge at the focus. So if we actually keep a small object exactly at the focus of this concave mirror in this setup, then all of the heat energy that the rays of sunlight are carrying with themselves, it will get concentrated at the focus, and that is the fundamental principle and the common arrangement behind a general application called as solar heating. So maybe you want to say use this heat for cooking food articles, or you want to use this heat for boiling water, and then you want to use that boiled water to serve some other purpose to use in some other setup or applications. So for that, the first thing you have to do is the object that is to be heated must be placed at the focus exactly. Then the orientation of the mirror should be set in such a way that whatever the rays of sunlight that are incident on the mirror, the rays are parallel to the principal axis as much as possible. Third, now if you really want to generate a very large amount of heat, then the overall diameter of the mirror, this much diameter, it is also called as the aperture of the mirror. The overall diameter of the mirror should be as large as possible, because larger the aperture, larger number of rays of sunlight will be incident on this concave mirror, and as a result of that, a very large amount of heat will get accumulated, will get concentrated exactly at the focus. So depending on your requirement of heat energy, we usually design the aperture, we decide the aperture. Now in this whole setup, an important precaution that we have to observe is in connection with the size of the object or size of any setup that we plan to keep at the focus. As you can clearly see that whatever you are going to place at the focus of this mirror, it is going to obstruct the path of the incoming rays of sunlight. Okay, so it is right in front of the mirror and the rays of sunlight are also coming in from that direction. Obviously, whatever you place at the focus will obstruct the path of the incident rays that are coming from sun, and that is why whatever we place at the focus should be considerably smaller in size, or should we say as small as possible. As a result of that, what will happen is the obstruction will be minimum, and so you will end up gathering maximum number of rays of light and concentrating all of them at the focus. Okay, second application, very much similar to this one. Suppose instead of gathering the rays of sunlight, what if we have taken a concave mirror and exactly at its focus we have placed a point source of light. like for instance an LED. So a point source of light is placed exactly at the focus of this concave mirror. Now, what is going to happen? This ray of light, this source of light is going to emit rays in all possible directions like this. So, of course, it is going to emit in forward direction as well. So, in that situation, let's remind us of a simple ray diagram of a particular incident ray that we have seen in the previous videos. Okay, whenever an incident ray is incident on a concave mirror such that it passes through the focus. So if it passes through the focus, after reflection, it will emerge, that is the reflected ray will travel parallel to the principal axis. So whatever the number of rays that are emitted by the source and they are incident on the mirror, after reflection, all of them will travel parallel to each other in the forward direction. So this principle is employed in, first, the reflector that is used in the headlights of two-wheeler, three-wheeler and four-wheeler, they usually are of concave shape. Second, this is a little bit rare, but still, if you have visited a doctor, particularly an ENT specialist, ear, nose, throat specialist, then they have this kind of setup mounted on top of their head like this, and it is fixed to their forehead using an elastic strap. Now, in that setup also, there is a small source of light at the focus of a concave mirror which is behind that light. So when they switch on the light, the reflected rays, all of them go parallel to each other. So they get a parallel beam of light which have a considerably large brightness. So they want to observe somebody's nasal cavity or the throat cavity or the ear chamber. So you need a very, very bright source of light. So this principle is employed. Also, another interesting application of concave mirror is because they are capable of producing a virtual, erect and a magnified image. Even the dentists use it for probing, for actually being able to see very small portions and details on the inner part of your mouth cavity. Because in every corner of your mouth cavity, they can't physically look into that. So they use a very small concave mirror, which now we remember that when the object is between focus and pole of the mirror, the image formed is virtual, erect and magnified. So there they make use of this important property of concave mirrors. So these are some of the commonly seen, observed applications around us where a concave mirror is employed, is used. All right. Thank you.